When on a collision course with the future, you can either adapt and survive or be left behind. Windsor-Essex chose the third option: help define the future and thrive. As a global leader in the development and implementation of automation technologies, we're the ones that build things that build things. With over 2,000 acres under glass, we bring low-touch, high-tech agriculture to the rest of North America. And we have over 1,000 manufacturers in our region with a particular expertise in automotive, aerospace, food processing, pharmaceutical, nutraceutical, and medical devices. Combine all that with a quality of life that celebrates outdoor lovers, sports fans, festival goers, and everyone in between, and you just may have discovered what you're looking for. Windsor-Essex, where Canada begins. Visit ChooseWindsorEssex.com to learn more.
Welcome everyone to Reboot the World. We are so excited to have Laura Sanchez with us for AI for Vision Zero. Take it away, Laura.
Wonderful. Thank you so much again. Welcome everyone. Thank you so much for being here today. Really excited to be participating in Campus Party and this Living Better stage. Today, I'm going to talk a little bit about mobility, about safety, and about data, which probably, at least the last one, you have heard many times throughout the conference, since it's an innovation conference, right? A little bit about me, just so you know, and especially for those that are in shifting industries or shifting roles and wanting to go into a more innovative role. My background is in industrial engineering, and about a year ago, I joined an innovation team with Siemens in their mobility department. And just tell you that, keep pushing. Sometimes it gets overwhelming, it's challenging, but it's great that you are pursuing more innovation and wanted to change things. So just that piece. For all of you that are trying to change roles. About my team, the team I work on, as I mentioned, is an innovation team here in Austin, Texas. And what we do is work with data. We create data-driven applications in the space of mobility. So what keeps me pushing when those challenges arise, and what keeps me moving forward is this team, these smiley faces here that I have the chance to share my professional life with, and also the vision we have in order to use data for the good of all. And I'm going to get a little bit more into that. So as I mentioned, our team does many different things in the space of mobility. Today, I will focus my talk in the safety area, as this is a health and science stage. But I just wanted to give you a glance of what we do and who we are, because I think it's nice to have that bigger picture of who am I talking to today, right? So we are a team conformed by product owners and innovation managers. I am one of the latter. We have software developers, data engineers, and data scientists that, with their expertise and our core business that has been working in mobility for several decades now, we're bringing data-driven solutions to cities and public agencies to help them introduce new topics, bring innovation into the city, and little by little making the city the place that the citizens want to live in. And all of this is driven by how we utilize the data that is already available in our cities, and combining with new technologies such as machine learning and artificial intelligence. So I'm talking a lot about data and what we're gonna and that's our vision, right, for my team and what I want to present today in the topic of safety. What we're gonna do and what we're gonna go through is to introduce a little bit of the topic of Vision Zero and how utilizing data we can bring more acknowledgement of what's happening in the city related to crashes. So how can we predict crashes? How can we stop those crashes from happening? So if you are very interested in mobility, and by now you already know that mobility is not only the infrastructure, but also combines the street lights, the traffic systems, the timing on the lights, and obviously now the data. You probably have heard about Vision Zero. So Vision Zero is a multinational road traffic safety project that started in the 90s, mid-90s in Europe. The first country that established Vision Zero was Sweden. And the project itself, what aims to do is to eliminate completely all road system fatalities and serious injuries. So when we look at a mobility system and we have many moving parts, we want to make sure that even when there is always room for the human error to happen, we want to minimize that as actors in that system. So Vision Zero brings many different preventive measures to how can we act when there is areas where we have a lot of crashes, for example. But some of those could be from changing the road design that we have in a specific area, if there is a very dangerous curve, to widening the lanes, to creating bike lanes, and many other different topics. Also, very important to have pedestrians in mind. For all of you that live I live in Texas, so here the roads are really big, are very nice, but when you want to walk, it's a little bit tougher to find places to walk safely. And so Vision Zero also prioritized these new methods, right? Like, well, if you want to walk, do you have the way to do it safely? If you want to take your bike, can you take your bike without thinking, I'm going to have an accident? And also Vision Zero compiles the policy making as well. It's very important then when we look at safety, especially in the road infrastructure, we look at from an engineering perspective, from an economic perspective, but also from the policy making, because if the policies don't change, then it's going to be very difficult to make that change and to bring that innovation into the industry. So mobility, it should mean an increase. It shouldn't mean that there's an increased number of accidents. So mobility is a big industry. It means economic growth. It means people moving from point A to point B. And unfortunately also means that there's an increase in traffic normally when the industry grows. To more traffic, there's more congestion, which many times translate in more accidents. About every year, more or less, 1.2 million people die in the road. So this is what we're trying to prevent by utilizing new technologies and helping us taking the right decisions at the right time. So we know that there's a lot of accidents in the road. For example, in the U.S. In 2019, about 38,000 people lost their lives. Many of them were not even in a crash where two cars were involved. Many of them were with objects. So we are now starting to see that these accidents could be preventable why are those accidents happening, right? And then we also have some statistics in that give us some information about who are the passengers that are more vulnerable. Is it the driver? Is it pedestrians, or is it any other type of road user? So with all of these statistics, of course, there's some questions that come to us, right? What a TMC, a traffic management center, can do to mitigate these accidents in the road system? How can I do, or what can I do as a traffic engineer to prevent these accidents from happening? Many traffic engineers know perfectly which ones are the spots where crashes happen normally, and by experience, they starting to analyze, and they starting to figure it out. Oh, this is a hot spot where I normally have accidents. What can I do to prevent this? So, or what we can do is use data. So data, as we all know, many different industries, probably every single industry nowadays, um, are generating a lot of data, and it's extremely important for us because with this we can drive actionable outcomes. We can understand what's happening in the system, and we can try to prevent it. We can implement systems that, uh, thanks to the computer power that we have, uh, we can understand what's going to happen in the future. How can I mitigate those actions from happening, or those events from happening, and we don't need to rely on people remembering, oh, there was an accident in that road 3 weeks ago, and there's another one, and then in 3 weeks there will be another one. It is a lot of information to keep track of, and there is a lot of time that goes by. So it's really tough for a traffic engineer to remember all of these things related to safety. Normally, they have a really good understanding of on where accidents happen, and they will start implementing measures. But they are at the point where technology can support them and bring them the data that they need in order to take better and more accurate measures against what they are seeing. So we utilizing crash data to improve safety in deployment strategies. I have been talking about this probably for the last 10 minutes, in which we have the data, we have the infrastructure. So I'm going to get into what type of data we get in order to analyze crashes, which is not only crash data. We can get other type of information into the system, so we better understand what drive the system to have more crashes in a specific area, and how can we influence cities by utilizing new technology into prioritize the areas that need the most instead of the areas that get more attention for whatever reason it is. You all probably know that some areas, just because maybe the citizens in that specific area really like those 311 apps, and probably you have one in your city. You can log in a lot of information there. So a lot of the cities, what they do is just to look at that information. If an area gets a lot of complaints, then let's put some budget towards it and let's fix something. But is that what we really want to do? Is that where the resources should go, or should we look at a more holistic picture of what is happening in the city and allocate our resources a little bit better and prioritizing a little bit more fairly? So for Siemens, for my team, we have translated all of these related to accidents that are happening in the road system, and the data that we're now able to get. The result for us is Crash Hotspots, which is an application that we've been working on for about 6 months or so. Being an innovation team, our lead time is very little, so we do a lot of different projects, as you probably remember from the tree that I showed before, in very little time. So we act as an agile team. We are a pseudo startup. As you see, we're part of Siemens, but we try to put pilots in place, really understanding if the solutions that we're bringing to the table can help the problem that we're looking at. So Crash Hotspots is a tool that processes incident data to predict where accidents are more likely to occur in the future, and also provide agencies with more information so they can deploy those strategies to mitigate the accidents. It also looks at vulnerable road users, so pedestrians, bikes, and motorcyclists, to really understand why those accidents are happening. And this is how we're helping the cities to achieve that Vision Zero vision that they have. So how the system works is fairly straightforward. I'm not going to get very much into the technical deep side of things, but as most applications, we have an input that is data. In our case, is traffic data, is crash data, and our engineers, as I mentioned earlier, have developed different machine learning algorithms in which they are capable to predict where areas are more problematic in terms of crashes. And what our customers get at the end of all of these data analytics is a visualization and reporting, but also a recommendation engine. So it is important for our traffic engineers to understand where the accidents are occurring. But if we have seen several specific inputs that are the same in two different accidents in two different locations, and we have a similar environment, then the recommendation to mitigate an accident in point A, it will probably very similar to be the same in point B. So having an engine that allows our traffic engineers to have recommendations, it is extremely valuable, because we then can minimize the time that they spend looking at the system, and also putting more effort into keep moving to the next, and understanding how can we make the whole system better. As you probably are imagining, many times when we fix something somewhere else, the system is going to start changing. So that's why we are relying heavily into artificial intelligence and machine learning algorithms, because we want to always be on top of what's happening and how the system is changing, and change with it. So the steps that we take in order to do this with Crash Hotspots would be to automatically identify our crash data. We map out and score the locations that are the most dangerous within the road system. We analyze what type of incidents we are looking at and the users that are involved into the system. So I mentioned before, pedestrians, bikes, cars. It's very different, the type of accidents that we have. And it has a different impact, not only economically, which is very big, but also emotional and social. Like we don't want to keep having these accidents and losing lives, because we can modify the systems. And nowadays with autonomous vehicles, we can do way much more than what we are doing. There's no room for that human error, for being distracted, for being on our phones. There should be no room for those errors when we can control the system. So we analyze those accident types and the users that are involved in the accidents, and then we strategize to develop some safety measures in those specific areas. And as I mentioned before, this point is a key point, because we want to prioritize based on how dangerous that area is, not based on many complaints that are coming from that specific point. But sometimes it might not be because it's the most dangerous area in the city. It might be because those that neighborhood, for example, is a little bit more outspoken, and they really like to be on top of their neighborhood, which is fantastic. And I think that we all should care for where we live and bring up these topics. But sometimes other areas get overlooked because of the data that is being looked at is just a little tiny piece instead of looking at the overall system. So for our application, what we do is to bring some crash data. Of course, we need some input. So we bring crash data from police reports. We also bring some external factors. We bring weather data, which influence a lot into mobility issues, as you probably can imagine. Anything that, I mean, everybody probably has driven or been in a car, so everybody can understand, or even being a pedestrian can understand that weather will impact how we perform in the road system. We also bring traffic detectors. There is a lot of detection within the road system. And it is interesting because in my personal perspective, coming from an industrial engineering, I didn't have a lot of background into the mobility world. And when I got here and I saw all of these amazing things that they were doing within mobility, with all of the traffic detection that they have in the roads that we don't even see, all of the intelligence behind the cameras that we have, and all of this data that we're generating, it really surprised me. I was not expecting all of this, just being purely out of the industry. I was definitely not expecting that there was so much intelligence behind. I thought it was like, okay, green, red, I go, I don't go. So I think that's really amazing that the industry is really keeping up with the technology and moving forward and bringing new detection and creating new data. So those are some of the inputs that we have for our application. And so what we get as an output for our customers, as I have mentioned before, is a map with the top crash hotspots within a city, whatever city we're talking about, the type of road users that we are seeing that are having the highest number of accidents in that area, the type of collision, which is important, especially here in the United States. It's very frequent to find wrong way driving accidents. I haven't seen those as much in Europe, but it's very important to understand when these wrong driving accidents happen, because these are actually, quote unquote, very easy to solve. Is a matter of putting a new sign, is a matter to getting the driver's attention a little bit differently. So it's something that it can be solved in an easier way than other type of accidents. And then we also look at fatalities versus non-fatalities. As I mentioned before, the main goal of Vision Zero, which is a strategy that cities are trying to follow in the States and also in the world. There's other countries that are involved into this project, is to reduce the number of fatalities to zero, and as well as serious injuries. So sure, we will still have some accidents, but we don't want anyone to lose their life in the road system. So it is important for us to understand fatalities versus non-fatalities, so we can also prioritize those ones where the accidents are more harsh, where people lose their lives. And so a little bit of how it looks like for us. As I mentioned before, I won't get too deep into the tech side, but if you have any other questions, I'll share my contact, and you can contact me later. We can discuss a little bit more. But this is basically how the structure looks like for our crash hotspots application, in which we have some data processing. We create the map with all the crashes and the dangerous zones. We bring onto that prioritization of where is the areas that are more dangerous. We would bring some countermeasures based on the infrastructure that we have and some of the data that allow us to compare what the system is telling us on this is a very dangerous hotspot versus the cameras that, for example, we have. Can we match up those results? Brings those countermeasures We also are talking about connected vehicles. So if there is a spot where you're driving and it's a hotspot for crashes, it's an area where a lot of accidents normally occur. You can get a small sign that says you're going through an area that is dangerous. Please reduce the speed. Or please change the lane. Something like that. There's many different basic messages that we can send to a connected vehicles. And now that we're also talking about autonomous vehicles in probably very near future, the car will already be able to just take the actions instead of letting the driver take the actions. And also the system itself, so the lights can help to do that, to reduce those accidents. So maybe it's a light that at some point start blinking red, so you need to stop, and that will allow you to continue in like a second, but like you're already influencing the system to prevent that accident to happen. And then the layer 4 that we have here is that integration with the recommendations that we do for the traffic engineers. So all of these, as I mentioned, you can see it on the right. It has a lot of applications on how we can better take care of our citizens related to how we perform in the roadway. And there are very different scenarios where we can implement this type of applications on understanding and knowing where crashes are happening. So some of the applications we have there are near misses detection, understanding, for example, from connected vehicle data that we currently have, where there is a near miss that could have probably be an accident, but never happened. So those give us a lot of information as well. I hope that you now are seeing all of this, how it's being put together, right? When we have a near miss, that could be an accident. So we might need to start looking at what's happening in that area to prevent accidents from happening in the future. So to wrap up my talk today about Vision Zero, about how can we utilize data in order to help cities to perform better and to bring that city that the citizens want, to make it more intelligent, to feel safer. I just wanted to outline a couple of the benefits that data analytics bring into the public sector. And those are that by having an automated approach to traffic, traffic agencies can minimize the efforts and the investments that they are required for in order to prioritize the infrastructure development and in order to prioritize where their budget is going. So as you can imagine, all agencies have specific budgets and they have to decide. But if we give them a little bit of more objective intelligence based on data, then the efforts that they have to put in are going to be minimized. So I think that's one of the key benefits that we can do by bringing data into public agencies and this type of innovation. We also focus on crash-prone locations that will maximize those benefits from intervene from the TMC, from the Traffic Management Center, and also integrating these crash hotspots analytics with the systems can alert the drivers while they're going through those locations. So applying data for a good cause is one of our visions at the Digital Lab, at the ITS Digital Lab. Better allocate those resources that we have and help the cities to better understand how can distribute their resources. Also influence the policy making and bring some intelligence to that policy making and make sure that it makes sense for the greater number of citizens, and also acting fast. I think that because, as I mentioned earlier, because we're putting all of this intelligence behind these systems, if the system keeps evolving, which it will, then we will keep, or we will be able to evolve with it because we have an intelligent system behind instead of relying only into the human expertise and the human memory, which I have to say, I am always fascinated by what we can do as humans, but I think that having that support from the technology is fabulous. So with that, I'm gonna leave some room for any questions if there's any. Um,
So we'll give everyone a couple of minutes to type in some questions into the chat. Let's see. So the first one is, where has this project been implemented?
So right now we're working with the city of Ann Arbor here in here in Michigan in the states, and as of right now, this project is being piloted there, and we are actually looking for other cities to implement this solution to find different environments where we can find different KPIs as well. I think that an important part of mobility systems is understanding the environment where we work because it's not the same to be driving in southern states than northern states. One of the main influential factors, as I mentioned earlier, could be the weather. So as you all can imagine, we would like to have a very diverse set of cities that where we can implement these type of tools.
Cool. Awesome. And then are y'all working on any international projects right now?
So with this specific application, we're not, but we are an international team. So we have a set of experts here in the States, which I mentioned we are located in Austin, but we also have another office in Munich that is doing some other projects related to data-driven applications for the mobility sector, and we have a small office in Singapore as well. So we try to cover the whole globe as much as we can. Yeah, we collaborate with each other because many times we are capable to bring some of the solutions that have been implemented in other countries over to the States or vice versa.
Cool. Awesome. So it looks like that's all the questions that we have. So thank you so much, Laura, for your wonderful presentation. It was very, very insightful.
Thank you very much, Jen, and everyone. I hope you have enjoyed all the sessions today.
Well, again, thank you, Laura, and thank you everyone for joining us. And now we will do a shout out to our sponsors.
Hello, I'm Robert McGee, Executive Director for the Engineering Society of Detroit, and I'm a proud supporter and sponsor of Campus Party Digital Edition. For 125 years, our society has promoted engineering excellence and innovation, from the rise of the auto industry to the fourth industrial revolution we are experiencing today. Through it all, engineering and technology leaders in Michigan, the state that employs more engineers per capita than any other, have been at the center of our progress. This summer, you have the opportunity to get a taste of Campus Party virtual digital experience. And next summer, the live experience will be held in Detroit in the summer of 2021. Michigan is home to 22 colleges and universities with A-Beta engineering programs. We hope you will join us.